All right, you guys ready? Let's rock and roll. It's been great seeing everybody at DevCon, and they've done another fantastic job of putting this thing on. I mean, man, they even brought Iron Man. That thing is freaking incredible. You guys seen that? I can tell if that thing was a robot or if it was for real. Like, hey, don't taste me, bro. Thanks for laughing, by the way. Giving a talk about MongoDB and NoSQL and all of its awesomeness, and I think the majority of the reason you guys are probably here is because I put awesomeness in the title. So what are we going to talk about today? Talk a bit about what is MongoDB, pros and cons to using MongoDB, performance, and stored procedures, which is something that I know we haven't used a lot of at Cerner up to this point. Give a demo, which I think is the more interesting stuff, and then we'll talk about replication for all of your data, and then tips for some of the things that we've learned and some of the things to avoid or go try and do. So what is MongoDB? MongoDB comes from the word humongous. It's a scalable, high-performance, open-source NoSQL database. It uses JSON-style document storage called BSON, which is actually binary JSON, and BSON is actually it's a superset of JSON, and they have very similar data types, except BSON actually has a few more. They don't have, JSON's got a very generic number type, and BSON actually has integers and floats, as well as a few other minor changes. And then one of the other differences from a performance standpoint is BSON actually prefixes its large elements with length information, which helps for searching, which improves performance pretty drastically. And it also uses memory map storage for all disk I/O, which also helps with performance because then your cache and your data become the same. You don't have to worry about data redundancy. Terminology. So some of the things you'll hear me talk about throughout this presentation are database, collection, documents. So a database is made up of many collections. A collection is made up of many documents. And you can think of collections kind of as a table, and you can think of like a document as like a row on steroids, and everything that you ever wanted to do with this row in a traditional relational database basically can do in its document storage. Why should you use MongoDB? Well, it's flexible. So since it's a schemaless storage, you can basically add or remove keys anytime you want, which has been super awesome for some of the stuff that we've worked on, because anytime we want to add something new in, it's not these huge database changes. It's basically you just start using a new key, which is great. Same way, alternatively, if you don't want to use a key, you just stop using it, and then you can go up and clean your data if you want. It's fast. Indexes are stored in memory, which, like I said, it alleviates the need for an additional cache since it's memory mapped. It's easy to scale with replica sets and sharding. There's a lot of people who use MongoDB that they'll add additional replica sets in during their peak load hours, and then they'll turn those off for at times where they don't see as much traffic, because you can read from secondary replica sets, which can help with performance. It uses atomic updates, so basically it's all fail or all succeed calls. When you're making updates to, like, let's say a single document, you'll never have an issue where part of the command is successful and then part fails, so it would give you really inconsistent data state, which never happens. And it's free and open source. Can't really beat that. Why should you not use MongoDB? Well, it's non-transactional, so you can't use for things like complex updates, you can't do rollbacks. There's less flexibility with querying, as in there's no joins. So you can't join one collection to another collection, but if you design your documents in a manner that you really need them, you don't really need to do that anyways, because everything that gets pulled back, you're pretty much going to have anyways. Document size limitations. There's currently a 16 megabyte document size limitation for each one of your documents. So if you want to put it's more about being conscious of how you design your documents. If there's a whole bunch of things you're trying to cram into a single document, it's not going to work. So you're going to have to think about your design. Ambiguous keys when shortened. This really only affects you when you're going into the Mongo console and trying to play around and look at raw data. Other than that, there's some other, I know one of the solutions we use is a Mongo engine for Python and Django, which kind of works as an intermediary in between your Mongo solution and your actual application itself. And this will allow you to store smaller keys because obviously the larger key you use, the larger the document size, and it'll slow down searching. Performance and indexing. So all your indexes are stored in memory, so you need to make sure that all your indexes can fit into RAM. So this is going to be a problem if you try to index absolutely everything. You don't have hardware enough to support this. Then you'll start doing disk reads, which will be really expensive and it'll slow down your application. Try to avoid single key indexes with low selectivity. So if you have a field, let's say, of status and it only has two possible options, active or non-active, you're not really helping your index out as much because there's only two possibilities there. So that index is really just going to take up a lot of space and not really give you much value. You can also use multiple key indexes. So the problem here lies if you try to do two indexes on a single field. So like in this example, if let's say we wanted to index on status and then you had a second index on status and created datetime, the first index actually is the one that becomes redundant and it actually won't get used because since the second one is more selective, it'll always use the second index. So basically it'll just be taking space in RAM and never get used. So you can see the good one is the third one where you just have a single multi-field index on status and created datetime together. To just random fields. Like let's say you were pulling back, you had a whole bunch of blog posts with the status of active and you wanted to sort them by created datetime. Hello? Just kidding. Stored procedures. So here's one thing we haven't actually dove into too much on some of the solutions we've used here at Cerner up to this point, but MongoDB can actually run JavaScript functions, which is actually a pretty cool functionality. And one of the big reasons why you'd want to do this is not having to transfer data over the wire, which can sometimes be costly. So if you just put that all on the database side and have the database run the stored procedures, you don't have to necessarily worry about the network being the bottleneck. The functions can be stored in a collection called system.js for future use. And here is a pretty simple call of what that looks like. That call is from like a Mongo shell. So the syntax, you can see the inserts. It's just it's the database, whatever database you decide to use. It's the collection name, and then it's whatever method you're looking to use. The one interesting one here is actually the update. So one thing the update does is it's got this upsert capability, and it'll either insert or update your document. If it can't find it, it'll insert basically the document that you're trying to pass in, and if it can find it, it'll do the update. So for our blog post example, we'll just do your simple CRUD functions. We'll create a blog post, we'll retrieve it, update it, delete it. Update, those are some of the methods that you can use, which we'll dive into some of those in the demo. So let's define our blog post model. So we'll say we've got three classes, pseudo classes. So we've got this blog post. It's got an ID, it's got a name, it's got the content, and it's got the author ID. Then you've also got comments that go along with that blog post, which have the author ID, comment, blog ID, and then you've got tags. So if you're thinking about this in traditional SQL world, you're thinking that these are probably going to be three separate tables, and then you'll have to do some kind of join, or somehow you'll go pull from these three separate tables. So if you look at it from the Mongo world, you'll see that it's all a single document. So you can store all this in one nice document where you can add additional things if needed. The only thing that could be extremely long here is maybe your comments. So one thing that could be an issue is since there's the 16 megabit limitation on document size. If you had a single blog post that had just tons and tons of comments, this could eventually become an issue, and you might want to think about your design and maybe change that out where comments actually is its own collection. But if you don't expect heavy usage or heavy commenting on these blog posts, then this would be perfectly fine to use. Demo time, baby. This is the more interesting stuff to me. Bullet points are very bullet pointy. All right, so we'll dive into the Mongo shell. And say I actually already have 3 servers running, along with 2 other replica sets. There's 3 Mongo instances running total. One's your primary and 2 are your secondary, which we'll get into in a little bit. So just a few simple commands. I want to see what databases I have available. And you'll see just some of the stuff I've been playing around with or testing out, or some of the other applications that I have running locally, like Cerner Health Winds is running locally here as well. So let's say I want a new database. So I'll do use DevCon. So I'll jump into DevCon and I'll say, show me what collections I have in DevCon. Right now I don't have any because I just created it. So let's go create some docs. So you see these are pretty simple docs. This is kind of representative of the example you just saw with the blog post, where we've got an ID, a name, author, some contents, some comments, and some tags. So basically you can create this inside your shell. Hopefully you guys can see some of this. So it just got repeated, the output got repeated. So doc is assigned to basically this blog post or this document. And then the simple syntax is DB, which is using DevCon right now, and then blog post is the collection I want to call it, and simply do an insert. And so once I have that, I can do show collection. You'll see that I have 2 collections that are actually created. And system.indexes will always get created for a field that's _ID. That will always get indexed on every field. So whenever you want to index by an ID, you should really use the _ID. So if we want to look at what just got created, we could say db.blogpost.find. .pretty just makes the output pretty. Makes it look it so you can actually read it. So you'll see that there's basically 1 there. So I can do a .count, see how many documents are in that collection. I've got 1. So let's go ahead and add another. So it's the same type of thing. We've got the document. Some things are different title, different ID, same author, and some pretty cool comments, awesome tags. So once we get those added, I'll show you that. Now you can see we have two documents inside the blog post collection. So that covers the inserts. Querying, showed you guys. The find one just finds you an individual instance of a blog post. This one, if we want to query by a specific ID, you could say, okay, well, I've got 2 blog posts. The first one is actually the one with this ID, so this is how you query by an ID. So one thing to note here is this object ID that gets created. This is actually a Mongo object, which we actually overwrite. You can actually use your own on this. So really what I would have done here, or what I'd like to have done, is just use this as my ID because it's easier to work with. Sometimes working with these Mongo objects can be kind of a pain in the butt, but they're guaranteed to be unique, which is nice, so you don't have to worry about uniqueness. Other than that, you're going to have to basically figure out which IDs are unique, which we have ways of doing that as well. How else? Let's say we want to pull back only a blog post that has, my criteria is just any, so it's basically just give me 1 blog post. I don't really care which one. And I only want to see the name and the author ID fields. The _ID field will show up all the time, but this basically will just return me the fields that I want to return. So I know if I'm on some kind of view where I'm only showing a subset of information, I don't have to pull everything back, and I can only pull back the relevant information. which will transmit less bytes over the network, and it'll actually work out better for performance. If I wanted to show everything but a certain field, like let's say I don't want to see comments. Let's say it's just all I cared was about the number of comments or something along those lines, where I didn't need to pull back all that additional information. It's just a simple preview. Well, I can say, okay, well I don't want comments, so give me everything but the comments. So then you'll see it return me all my fields and values except for comments. The other one was just querying by author ID, which you'll see this actually returns 2 fields since it'll return 2 documents since I have the same author ID for both these blog posts. And if this font wasn't so large, it'd be a lot easier to see. It's always nice going through the demos when you have like your full screen resolution. So for updates, this could be a bit tricky to read as well. So basically I set my criteria to say, okay, well everywhere I have this author ID, I want to set some new key. Let's say I want to implement this idea called is-featured, and I really like this author, so I want to make all of his stuff featured. Well, I can say don't upsert and do it for multi-occurrences. So this will basically give me all occurrences where for this ID I'm going to have this is-featured. Right now you can see I don't have that current field is-featured. So when I run this update, and then we pull back this author's stuff, we now have is-featured key, which basically you can start using it on the fly. I mean, it's ready to go. Since it's a schemaless document, I can basically add or drop these keys whenever I want. Another little bit more complex one is, let's say I want an author ID that has the tag of Buffett. So he's got 2 in here right now, and I want to say, okay, we'll set rockstar equal to true. So I come in here and you'll see that this guy only has the 2 tags Jimmy and Buffett. So that's the guy that's actually going to get changed. The other guy does not have it. So when I paste this in, you'll see that we're going to now have this attribute of rockstar equals true for the one that had the tag of Buffett. So you can see how easy some of this stuff is to work with. It's incredibly easy, incredibly dynamic. It can do pretty much all the stuff that you want to do. A little bit more complex is using a $ as a placeholder. So throughout my comments, the comments are actually stored as a list. It's a list of dictionaries or a list of documents. And so I can say, well, everywhere where I have you rock as the comment, I want to set the comment to be about rock equal to true. And in my 2, you'll see that you rock was actually in the 2nd blog post. So that's this guy right here. The other guy did not have anything that said you rock. So we're going to make this comment rock. So you see we added this additional attribute called it's about rock. And you'll see that nothing got changed in the other document. So add to set is probably one of the nicest features about Mongo, or one of the nicest features about Mongo. So basically, everywhere I have this author ID, I want to add a tag that says word up. So when we come in here, we'll say add to set word up. And what it does is it basically creates this list of tags, and it'll check to see if the tag already exists, and if it exists, it doesn't add it. It knows it already has it. So if I were to go to run that same command again, it doesn't get added twice. It knows it's already there, so it just doesn't pull anything back, which is a pretty strong feature. We use that quite often, which is nice for keeping your lists in order and making sure that you're not adding duplicate tags or duplicate whatever the value is that you want in your list. Stored procedures. So this is something I just started playing around recently. We don't actually use this, like I mentioned earlier, in production at all. So I don't know the implications of actually using this in production. However, this is more of just to demonstrate how this stuff actually works. So you can create JavaScript functions that you can call through the Mongo shell and through the actual application itself. This one simply returns, it adds additional fields if I don't have them. So through each one of these, let's say I wanted to start doing statistics on each one of these blog posts. Well, I can go through and say, well, okay, give me a number count, give me the total, and give me the average for all these. And then increment that each time on whatever blog post that I want to actually look at. So we'll store this function. So now this function is created. And then when I say increment by a specific ID, we'll just say increment by 2, you can see that I now have a number, a total, and an average on this specific blog post, the one that was actually matched in that function. And then if I were to do it again, say we'll go by 5, you can see that the values automatically change. So there was no, if you were to do this in your application, it would all happen on the database side, and you wouldn't have to transfer any bytes over the wire like I mentioned. It all stays basically right there, which helps with performance quite a bit. So performance and indexing. Let's say, so Mongo has this function called explain, and it'll basically tell me what's going on with my queries. So if I say, what happened here, it'll show me how long it took, if it used any indexes, how many items it found, and pretty much it's telling me right now that it's not using any indexes. And if I check the current indexes, you'll see that I only have one index, and it's by the underscore ID. So if I want to go add an index to this, I'm already using DevCon. So for show collections, like these are all my collections, and one of the collections actually is system.devcon. So I can go ahead and check that. And it's a little bit tricky how you can actually use a dot. You can use a point in your actual collection name, which gets a little bit confusing, I think, but it works, which is awesome. So let's say I want to ensure an index. So ensure index basically says that on blog posts, I want to ensure an index. I know some of you guys can't see that, so let's move it up the screen. Hopefully you guys aren't having that problem for all this stuff. But basically I want to ensure this index so there's an index on author ID and name. I know I'm going to use author ID a lot in my application, so that's something I definitely want to make sure that there's an index on. So now when I go and look at my indexes, I can say, okay, well now there's this other index that's also looking by author and name. And then when I go to make this call to say, show me this query where I'm looking for author ID sorted by name, it'll show me, okay, well I found this index. I'm using basically your index just created, and I'm reversing the order, which helps with performance. Showed you guys all indexes. There's other utilities that it has that you can come in and check out. Like I want to see the total index size. This is good for making sure that you're not going over the total limit that you have actually on the hardware, because that's when you run into issues. So you can see it shows it, I think in kilobytes. I don't remember what it shows in, but that's one way to make sure that you are able to fit all of your indexes in memory, because that's when you start running into trouble. So if I run into, we already read this guy. Yeah, and that's just showing you basically that we're actually using the index now. We're actually hitting the index, which is pretty useful. So if you ever had a question on like looking at all your indexes, you can go back and evaluate, well, maybe I don't need some of these other indexes because these other ones are being used. So for monitoring, there's a few different functions you can use. You've got db.stats, which will tell me, it'll tell me all about what's going on with this object or this collection. It'll tell you the size, the number of elements, the average size, pretty much anything you want to know. Server status, This was extremely useful for some issues we ran into in production that we had a whole bunch of trouble figuring out. And we noticed that the number of connections here was extremely high, and some of the stuff we were using with Celery for background tasks were actually, they're creating connections, but they weren't actually closing them properly. So we ran into an issue where we actually used too many connections and it actually brought down prod. That sucked. Another nice thing is I actually started all these with the REST interface on, and so if you come into a web console, let's go to, I've already got it fired up, but just so you can see it again. Okay, so you can see it's actually just a port. It's a port 1,000 more than whatever I ended up using, and so you can come in here and look at all kinds of status about your Mongo instance. I don't know if you guys can actually see this. Crank it up a notch. Maybe you can see some of that. Maybe people are sleeping and they can't. But this stuff's pretty cool. So you can actually come through here and see like all the build info, like what version am I on, operating system information. We don't have to get into this stuff in too much detail. Is this my master? See, the master is true. I mean, you can actually build a site around this to actually use some of these REST services that'll let you know like how everything is doing within your Mongo instances. So that's some cool stuff. And then below you can actually see the log viewer, which is pretty sweet. So I can know kind of what's going on. Like if I were to step the master down and it went over to a secondary on one of my replica sets, it will show you like all that stuff in here, and that can be helpful for going to evaluate, well, what just happened? Do we have network downtime? Did something happen with this box? What's going on? Replica sets. Replica sets, it's just a command to basically, oh. We don't have to get into this too much because this one's actually kind of boring. But basically you define the name of your replica set on the port number, where you want your logs, where you want the data stored, because the data is actually stored on files. So there's just a simple path here that goes to wherever we want the data actually stored. And I tell it I want rest on, and just to make it quiet when it actually kicks off. To delete things, so let's say I want to go ahead and remove something. It's just a simple call. So you'll see that both of them came back. There's two there. So if I wanted to delete one by its specific ID, it's just a simple passing the criteria in JSON format, and it's just the ID of that. And you'll see that when I do a count, I only have one. If you wanted to remove by author ID, same type of thing. If you want to remove the entire collection and just empty it, you just pass in an empty criteria and it'll remove everything. So, if we get back to the presentation, I actually put all that code in the slides themselves in case anybody wanted to go back and look at some of the demos. I just made that stuff available to you guys. So this will all cover the inserts, the retrieves, updates. So you guys can go look at that pretty much at your own time. It'll be posted out on probably Cerner. It'll be posted out on, I've got a Twitter account that I'll post it to as well. The folks over at Tengen love it when people present about their stuff. This deals with the replication. I mentioned earlier that, and this slide actually is kind of boring. It just shows the really technical stuff about it. But basically, when you kick off your processes, you basically have to just configure your primary to configure it to whatever port you're running it on. And if you want to add additional members in, you can just simply add additional members in. That stuff is all actually relatively easy to do. And like I say, you can do that when you're experiencing more load to help out your system with performance, and then you can kind of cut that back when you're not needing it. Tips: use small keys. So this example, let's say I had 1,000,000 documents and I had the keys of first name and last name. Well, those actually are quite a bit of characters when you go and multiply that by 1,000,000 each. It's going to take much longer to search for those than if you just had simple keys like FN or LN and then have some kind of mapping that maps it to the front end that makes it more readable. One of the solutions we ended up using, we didn't use any kind of mapper. Like I said, we mentioned Mongo Engine earlier. We weren't using Mongo Engine, so when we'd have all these keys come through the actual application itself, they actually come through as that. So we're having to deal with, well, somebody just added a new key. It's called K. Well, what does this mean? So you have to go back, refer to the documentation, and go figure out what that means in order to how you want to handle it. Be smart with your indexes. Use the multi-key fields with high selectivity so your indexes are actually relevant. And avoid redundant keys. That's more of the, okay, well, I've already got one field with multiple, one index with multiple fields in it, and it's pointless to re-index that other field with its first field because it'll never get used. Design your documents wisely. Think about your space limitations. So if you've got, you're expecting a whole bunch of data, you might want to think about not putting it all in a single document because you're going to have some issues when it comes to that. Hope you enjoyed. Hope I didn't bore you guys too much. You can reach me on at Troy Grossfield on my Twitter account. Stop by my blog. I post stuff about this stuff every so often. Good resource, mongodb.org, where I got a lot of this information from. And then for the whole feedback thing, you can leave a +1 or a 0 or a -1 in your comment card. Any questions?
Do you have any browser, like GUI interfaces that you'd recommend to use other than just using the REST web interface?
So the question was, are there any GUI interfaces that you can use outside of just the generic one that comes with MongoDB? There are a few out there. We've actually never used them. We ended up writing our own diagnostic tools that pretty much did the same thing because they're pretty simple calls. It's just a single call to get back a dictionary of information, and then you can display that information pretty easily. And that way we don't have to worry about security, tying in security to this other system we have with basically whatever ports it's on. So they are out there, we just haven't used them.
There's actually a list of the 10 free ones on the MongoDB page.
Yep. So that's where you can find them.
Yeah.
I got
So he's asking about replica sets and kind of the primary versus secondary concept, which I'm kind of glad you brought that up because that's the whole purpose of the secondary instances. So there was 3 replicas, which is what we normally use in production. And if the primary were to go down for any reason, where the 2 other replica sets can't say like, hello, are you still there? We can't see you anymore. Then that immediately will go into a secondary state if it's still functional, and one of the other secondaries will actually pick up and become the primary automatically. So that's a huge perk of replica sets. We've actually had that instance happen a couple of times where it bounced over, the primary box went down, primary server went down for our database, and they automatically, the 2 replica sets automatically picked up and kicked off. And then we get notified via email that you've got a problem, your primary went down, and then we can go fix it while production is still running. And the reason we use 3 replica sets is in case the replica goes down, and then there's only 1 sitting there. So we always have a backup up until basically two things go down. And the 3rd one goes down, it's just, yeah, we automate. All that stuff is automated for us. Yeah, and scripts. Yeah, and the reason we don't do that is because we like to get on the box and actually see what happens. And if we fire off like an NAD script that goes and kicks all that stuff off automatically, there could be some issues there because one of the projects we were working on was tied to Amazon. And so if we go kick off all these additional boxes, we just never really had a need to. I think if we ever had a case where we had the primary go down and the secondary went down, I think we probably would have been a little more scared and said, yes, you definitely need to do this, but we never had an instance where we weren't pretty much right on it. Because as soon as we got those emails, I mean, we were acting on it almost immediately.
So those emails you have during office hours or something like emails?
So this is the beauty of prod support, is you are on prod support all the time, 3 o'clock in the morning, 12 o'clock on a Friday night. Like it can be a nightmare sometimes, but it's nice having the flexibility of, we had a team working on it, so it was, hey, can you guys get to this? And the majority of the time, everybody could get to it. And we didn't have too many of those midnight on a Friday night where everybody's out and can't really get to their computer situations. But it worked out well, and it was always a case where somebody could get to their computer. Go ahead.
For example, when you have comments, like there's an area of documents. So if that area gets big, you suggested we can use a collection instead of JSON. So still we can query. So it's a collection inside another document, and we still can query everything.
So what you end up doing in a situation like that is, so his question was, you have a bunch of comments in your document, and I gave the example of, okay, well, let's say that those comments, that list just gets absolutely huge, and you're going to worry about space issues. You can go through that in a separate collection, and basically when the document comes back, or when the blog post would come back, you'd say, okay, well, you'd make a second query based on some unique identifier, like blog post ID, some foreign key ID, and then you'd go retrieve all those values. And that's what we do like for the user ID, and the user ID would have been the same way. And the user ID would have actually been a separate model because it wouldn't make sense to put it on the blog post. So we'd say, okay, well, who's this user? We get the ID, and then we actually go make a second query for that ID. But it's not really a second query. All the queries happen at once. But that's how you handle that.
Like you talked about the REST API, like, does the REST API expose more than just the status type information?
Yeah, there's all kinds of stuff on there. I actually couldn't go through it too much because we're about to get to time. But there's a whole bunch of information it gives you. I mean, pretty much anything you want to know, it's on there. Like, is there anything particular you're curious about?
So whatever you were doing through the console, can you do the same, like for instance, inserting new documents, writing documents?
No, you can't. So he's asking about, can you insert documents and do that stuff through the REST API? Actually, I don't know about that. Through that one specifically, I don't know. The application we use Python and Django, and so they have a driver called Mongo, which we use, and that's basically our interface to the system. So I don't know specifically if you can use REST API to add things, but I think you can definitely manipulate stuff because there's set functions on there. Yeah, just see me afterwards because we're going to run out of time before I can actually show that. We built our own. So we built our own system on top of that actually let us, they were in scripts that actually alerted us instantly when that stuff would go down. So we had emails for pretty much everything. Any problems we have with the system, whether it's a 500 or you can no longer ping the system, you use ping for that. You get the emails pretty much right away, and we're on it right away.
You were using something like a mixture of JavaScript and JSON in your updates. Is that some kind of a specification or a standard between all NoSQL databases, or is it specific to just this Mongo?
Yeah, so the question is kind of the difference between JavaScript and using JSON. Using in the shell, the shell is fully equipped to run JavaScript, so you can run pretty much any JavaScript you want from there. So
is there a standard for NoSQL databases, or is that specific to MongoDB?
So you asked if that's a standard to be able to run JavaScript.
Can you spawn a different database with your app?
Don't know.
Couch
I don't know.
Couch uses JavaScript too, but it's different.
It's NoSQL.
Well, it's the same thing like Mongo.
Yeah.
It's JSON for your data structures, JavaScript for some your language, but it's flavored just for different database structures.
Right. So the majority of this talk is talked about MongoDB, but it's more a lot of the same principles apply for all the different MongoDB solutions with subtle differences along the way. So if it's something that you're interested in, I would say, yeah, go out and browse for NoSQL solutions and try to find one that best suits your needs. Any other questions? Thank you guys for coming.